Okay, in chapter 6, we're going to start looking at the accumulation of change, and we will continue to do so for several chapters. Okay, so for 6.1, the first idea they introduce is the area under curve. This is the curve they're talking about. It doesn't have to be curvy, whatever that is graphed. When they say the area under the curve, they actually mean the area between the graph function and the x-axis. So for this first curve here, this is the graph. I want the area under the curve. I want the area between that and the x-axis, which means I'm really looking at this part under here. Okay, because this is above the x-axis, this is actually going to be a positive area, which normally it is, but the next one's not going to be. Okay, so it says area under the curve, but remember that's between this and the x-axis. In this case, the x-axis is up here, so the area under the curve ends up being above the curve. But it's just between the curve and the x-axis. If I had drawn that nicer. Okay, because this is below the x-axis, this is going to have a negative area. And then for this last one, it's kind of a combination, but we're still going to go to the x-axis. So I have this little area over here. I have this area up here. Then I have a little more area down here. When it's separate pieces, I'm just going to add the area of each of the regions. Okay, now when you're doing the units of this area here, you're going to do the units of x times the units of y. When they say accumulation of change, they're going to add up the areas depending on the domain they give you. So in this, if this was going by 1, 2, 3, 4. If they asked me for the area from 1 to 4, I would find the area of this little region right here. Well, let's go do someone. Okay, for the first example, let's look at like the most basic type of thing. Okay, it says during a road trip, your car travels on cruise control at 60 miles per hour for 4 hours. How far has it traveled? Okay, we're doing accumulation of change. So the function that we are graphed, the y-axis, that's going to be some kind of rate because it's measuring a change. Okay, now if you were just doing this in your head, you'd be like, oh, 60 miles per hour for 4 hours, 60 times 4, that's 240. It is 240. But let's look at it geometrically to see why that is the case. Okay, so he's going 60 miles per hour for 4 hours. So I'm measuring the area of the region between below 60 and the x-axis and from 0 to 4. So this is the area I'm trying to find right here. Okay, I'm going to do the units so we can see why the units are the way they are. But if I were doing the area of this rectangle, it would just be base times height. So in this case, the base is 4 hours. The height is 60 miles per hour. Per hour. And if I multiply that, I get 240. The hours cancel, which is why my units are 240 miles, which is what we would logically also figure out. Okay, now let's consider an example that's not just a rectangle and you couldn't just do it in your head. Okay, so for example 2, the graph represents the rate at which water is leaking out of a tank. So this is a rate, it's gallons per minute. How much water has leaked out after 9 minutes? Okay, now the rate it's leaking is not consistent. It follows along this path. Okay, so I want to add up all the water that has leaked, or the accumulation, over how long? 9 minutes. So I actually want the entire area. So I'm trying to figure out this entire area over here. Now how you divide it up is up to you, but I'm going to look for a rectangle first because those are kind of easiest. And it kind of looks rectangular-ish over here. So I'm going to make a rectangle going all the way from here to here. I think that's as big as I can do on that one. Do I want to squeeze my work in here? No, I don't. I'm going to call this area region A. So for region A, it's a rectangle, so the area is going to be 6 times 2. Let me put it over here. So that's already 12 gallons. Okay, let me just look at this little triangle over here. Let me find the area of that little triangle. It's going to be half base times height. So half, the base is going from 6 to 9, so that's 3 units. The height is 2, so that's going to be 3. And then I still have this weird little semicircle at the top, so that's a half circle. I'm going to call that C just so I can label my work on the side. Okay, now the area of a circle is pi r squared, but I only want half of the circle, so let me do half of the circle. What is r though? R is, if this is the center, r is 2. So that's going to be half of 4 pi, which is 2 pi. Okay, so now let me go ahead and add up the area of all those regions. 12 plus 3 is 15, plus the 2 pi, and then I'm going to get my units right. So I'm going to do gallons per minute times minutes. So the minutes are going to cancel. Now I have 15 plus 2 pi gallons. Okay, let's go ahead and consider one more. Okay, a particle is moving along the x-axis at a rate modeled by r of t shown below. So this is the rate, this is the time that has elapsed. Okay, how far is the particle from its starting position at 10 seconds? Okay, so I want to find the area all the way from 0 to 10, which means I've got this piece, I've got this piece, and I've got that piece. Okay, let me just start with one of them. Okay, I'm gonna still label this A because it doesn't really fit. Just be careful. That is a triangle, right? So that's gonna be 1/2. The base is 2. Be careful, the height is actually 10. So that's going to be 10. Okay, now let me do that other triangle on the other side. This one over here. I'm gonna call that B. 1/2. The base is also 2. The height's also 10. So there were 2 of those. Okay, now let me consider this trapezoid at the bottom. Do we know the formula for Okay, we're gonna learn the formula for trapezoid. Okay, that's a trapezoid. It's gonna have a negative area, which I can incorporate into the formula rather than have to think about it. Area of a trapezoid, half height times b1 plus b2. The height is gonna be this way, which is actually -15. And I'm gonna add the length of the bases. So this little base is 2, and the big base is 2 to 8, 6. So 2 plus 6. So 2 plus 6 is 8, half of 8 is 4. 4 times -15 is -60. Okay? And I was expecting this to be negative because it's below the x-axis. Okay, so how far is the particle from its starting position? So I'm gonna do 10 plus 10 minus 60. Which is gonna be -40. Okay, let me think about my units and then think about the question. So it says, how far is the particle from its starting position at 10 seconds? Okay, what is this record? This is the x-axis. So it's on the x-axis at -40. So let's see, I'm gonna say it's 40. What are my units? Centimeters per second times second is centimeters. And since it's negative, it's gonna be to the left because we're going along the x-axis. Okay, last question. It says, how far is the particle from its position at t equals 2 after 6 seconds? Okay, so starting at t equals 2, which is right here. 6 seconds later, it's gonna be right here. So we're actually just talking about the area of region C, which I already found to be -60. How far is the particle from its position? So it is 60 centimeters. Since it's left, it's to the left of its starting position, or left of where it started at t equals 2, I should say.